Okay, in this video, we move on. We stay in multiple linear regression, but we're going to modify it. We're going to still assume that our variables are continuous. They take on any number, any continuous number. They don't have to be a whole number. And but our independent variables, we're going to allow some of them to be categorical. And that means that they don't have to be numbers. So the worksheet that we're going to be looking at is this dummy worksheet. And the reason it's called dummy is because the type of variables that we're going to use are dummy variables or binary variables, indicator variables. They're called all those different things. So here's the problem. We're trying to determine how much a car is going to sell for. And these are some data that we have. So this car, this used car, sold for $14,600. It had 37,000 miles on the odometer, and it was a black car. And then I could pick another one. This car down here had a different set of miles, and it was also black, but the one right below it sold for the same amount, had more miles on it, but it was a red car. So when you look at those two, it says, wow, it's the same amount, and it's older, or it has more miles on it. Why did it go for the same price? Well, it's red. So maybe there is an impact of color on price. But color is clearly text. So what most people think that they ought to do is replace these with a code like 1, 2, and 3. And that is way wrong. That is exactly what you do not want to do. Don't replace these. But if I don't do anything, regression won't let me do anything when you don't have numbers. So here's the trick. This is what you have to do. You have to replace these variables with with dummy variables. So what you do is, first of all, you list all your categories. So in this case, they're colors. And I got black, I got red, and I got other. It doesn't make any difference the order. But once you list them, then you have to follow that when you build your dummy variables. So I have two dummy variables I have to build, dummy 1, dummy 2. Why do I have two dummy variables? Because I always need one less dummy variable than levels that I have. So need 2 since we have 3 colors. If I would have a fourth color like silver, then I would need a third dummy variable. So you're building this mapping scheme where we're going to map these, we're going to transform these into a new description, and we need to have 2 variables to describe it. The very first row, regardless of what these say, don't look at those, but the very first row you always just put zeros. Then you put an identity matrix, which is just ones on the diagonals and zeros everywhere else. Like that. So if I had a different color, another color, then I would need a third dummy variable. And I would put that 0, and I would have ones on the diagonals and zeros everywhere else. Like that. Now we don't have that, so I don't have to have any of these things for this problem. But if we did, that would be what we would have. So now that we have this, what we're going to do is replace this color, and I'm going to insert 2 columns. I'm going to call this dummy variable 1, dummy variable 2, whoops, dummy variable 2. And then wherever I have a black, I'm going to put in the new scale. So since it's black, I'm going to put 0, 0, like that. And I don't need these to be decimals. They're whole numbers. They're whole numbers. Like that. And then this one, because it's black, would also be 0, 0. And then other would be a 0, 1. Well, obviously, I don't want to type in these numbers all the way down. It's going to take a long time. So I'm going to write a formula. And look at dummy variable 1. Essentially, it is an indicator variable, and if it's red or not. Because if it's red, it's 1, else it's 0. So I'm going to say equals, if this value equals red, put a 1, else put 0. And I can copy that all the way down. So there you go. I've got a dummy variable that when this is 1, I know it's a red car. Red car, red car, red car. But if it's 0, I don't know what it means. It's either black or it's other. That's why you need to have two dummy variables, because combined these completely describe the color. So for this one, let's get rid of all this. For this one, if it's another, so this dummy variable 2 represents another, equals if the color equals other, put a 1, else put a 0. Now this completely describes. So if I would hide this, I would know that that is a black car, an other car, because there it is, another car, a red car, and I could do that for any of these. There's a black car, there's a black car. So these replace the color now. I don't need it anymore. I could get rid of that. Once I've done that, now I just do regression like I always did. I go under data analysis, go to regression, grab your data. I'm going to grab my Y variable, which is column A, and then my X range is these three. Whoops, let me finish up. I've got labels in my first row because I grabbed row 1, and I'm going to put the output right on this sheet. I'm going to put it starting right there. And there's my output. So same thing as before. Let's follow the rules. Look at this one first. Is that number less than 0.05? Yes, it's a very, very, very small number. If I want to show it and try to show this, it's basically 0 until I get out to 25 decimal places, which is, really, really small. There you go. Finally hit that. So that means that there's something adding value. Absolutely. The next thing we look at is R squared. Right there. Look at that R squared. It's really high. So that means 70% of the reason that we sell a car is based on these three variables. If it's the color and the odometer. Adjusted R squared. Look at it. Is that within 5% of this? It is. If I go take this minus this divided by what I started with and show that as a percent, I'm well within my 5%. So I got an efficient model. Now I go down here and look at what the important things are. So I'm going to take this data, I'm going to sort it, data sort, and I'm going to sort by column, in this case it's column K. And I didn't have to change anything because there's the, so now I'm looking at these three. You don't ever look at the intercept p-value, just ignore that one. I look at these three. So by far the most important thing is how many miles are on it. And for every mile you put on it, the price drops down by a nickel. As this goes up by 1, this goes down by, well, about 6 cents. So the more miles you put on it, the lower the price drops. But look at this one. Dummy variable 2 represents a red car. So when it is 1, that means my car sells more than the base. The 0, 0 are always the base. This is the base. So you can look at these numbers, these dummy variables, relative to the base. Not based, base. So a red car, that's what this is. This is a red car. It sells for $239 more than a black car. And another car, a car that's a color besides these two, regardless of what that is $91 less than a black car, the base. That's what these represent. So if I wanted to know, what's the difference between a red car and another car? Well, it would be equal to this minus this. It would be $330. So the difference between a red car and another car that's not black would be this. And the most important thing on the colors of red, if you got a car that's red, it seems to be worth more than any other color. It's highly significant. Okay, that's the same thing. That's regression when the trick you have to put in dummy variables. Thanks.